Welcome back. I'm going to walk you through query optimization in Polars step by step so you can boost your data processing skills and achieve amazing results. When building data pipelines, you might perform a number of manipulations on your data frame. These operations take time and computer resources to perform. When it comes to processing large data sets, optimization is absolutely essential. When you utilize LazyFrames, you're automatically taking advantage of the Polars Query Optimizer. This optimizer essentially evaluates your data manipulations and may change the order of operations so it can run more efficiently. Now, query optimizers are nothing new, but if you previously used pandas, it may be a fresh concept in the context of data frames. Our goal here is to provide a lens into how the optimizer works and why you might want to start using LazyFrames to build your data pipelines. With that said, let's jump in. Now, there is one important prerequisite that you should be aware of, and that is Polars uses a software called Graphviz to display a visual representation of the query plan. I'm not going to lie, installing this extra bit of software is sort of a pain in the butt. Not only do you have to download it, but you also have to make sure that it's accessible in your path environment. With that said, if you want to follow along and see the visual query plans, you'll need to figure out that piece first. Otherwise, we'll also be showing you a printed version of the query plan, which will work just as well. Okay, first we need to read in our data and perform some transformations. So we're going to come into this first cell here and import polars. And now we need to use the scan CSV method to create a new LazyFrame. So let's create a variable called LazyFrame and set it equal to pl.scanCSV. And from here, we're going to pass in our credit card transactions. Now, once again, just as a disclaimer, this is not real credit card transaction data. It's purely just for educational purposes. And it does have a column in there that has a date. So we're going to use the try parse dates parameter, set that equal to true so we can get the correct data type there. Okay, let's go ahead and run this. And now that we have our LazyFrame, we can go ahead and perform some transformations on it. So I'm going to actually just copy and paste from my notes and explain a little bit what's going on here. So we've got a couple different operations that we're doing. We're doing a group by the category, as well as a summarization of the amount. And we have a few other things going on, such as filters and a sort, and also a unique transformation. So quite a lot of different transformations going on here. Let's go ahead and run this, and you should see the naive query plan. Okay, so what we get back is a visual representation of our query plan. Keep in mind that this is where you need the Graphviz software. This is called the naive query plan because it is not optimized. Now, in order to read these visuals, you read it from bottom to top. So this is the first operation that occurs, and then as you go down the line, those are the subsequent transformations that it does. There are some fancy math symbols here, but their interpretation is really not that difficult. If you see a pi symbol, it means that you're choosing certain columns. In our case, we see an asterisk to indicate that the plan will select all columns of the 5 that exist in the CSV file. The other symbol is a sigma, and it indicates filter conditions. Now, we do have a filter function in the transformations that we performed, but it occurs later because this is how we wrote it. So normally if it was done right at the beginning, you'd see the sigma symbol here. In our case, it's just up here in this extra filter step that we have. Now, this visual representation is not the only way to inspect and look at the query plan. We also have the ability to print it. So let's demonstrate that now. I'm going to scroll down just a little bit here, click into this cell. And then we're going to type print and then transformed LazyFrame. That's the variable that we defined earlier. And then we can use what's called the explain function. And in here we're going to pass a couple different parameters. The first one is the format. So by default, the format that we have is not super useful for visualizing per se. It does help, but it's not as good as this other option that we're going to pass in here, which is the tree format. And then I do want to make sure that this is going to be the non-optimized version so that you can see the same exact query plan that we had above. So let's go ahead and type optimized and set it equal to false. Okay, let's go ahead and print that. And we're going to have to scroll up just a little bit. It is kind of harder to see in Jupyter Notebooks here. We can expand this element here to see the full query plan. But you can see it's very much like the other query plan that is in the Graphviz version. You have everything here, and again, it's read from bottom to top and basically gives you the exact same information. In some cases, a little bit more information than probably what was in that other one there. Now, I would be curious to know how long it took Richie or whoever developed this bit of code to create this text-based visual. I mean, it is super complicated and actually quite beautiful. In any case, it gives us another way to view our naive query plan. And once again, if you don't want to go through the trouble of installing Graphviz, this is a great alternative. Now that we have an idea of what query plans look like, we can get the optimized version for our current data frame. We do this by using the showGraph method. And we'll do that in the next cell below. So I'm going to come down here into the next cell, and then I'm going to once again call our transformed LazyFrame variable. And this time, instead of using that explain method, we're going to do the showGraph method. Now, this is going to optimize our query plan, and it's going to change the output a little bit. So let's go ahead and run that now. So in the output, our query plan has changed and we no longer have the filter step. Why? Well, filtering is more efficient when done sooner in the process. So Polars has pushed it to the very first step on when the data is read into Polars. And as mentioned before, we now see that sigma symbol. And again, that just means that we're filtering. We are also filtering out the number of columns here. So instead of seeing the asterisk that we had before, we now just have those 2 columns. What this really highlights for me is that I wrote a somewhat inefficient transformation. I should have done the filtering sooner in the process, and this is where the concept of lazy comes into play. As a data pipeline builder, I don't need to think through all of the details when performing transformations. I can be lazy and let Polars sort out which manipulations should be done sooner. Now this is all great, but how much of a performance improvement is this actually? Does it really matter if I place the filter in the wrong spot? To test this, we can compare the 2 queries, both mine and the optimized one. We can do this by calling the profile method off of our LazyFrame. Okay, so I'm going to come into this cell down here, and I'm going to once again call our LazyFrame variable. This time I'm going to say profile, and then I'm going to be comparing the 2 plans. So in this case, there's a parameter called no optimization. I'm going to set that to true, and this is going to give us the plan that I initially created. And let's go ahead and run that. And in the output, we get the result of the data frame, which is up here. And then we also get the amount of time that it took to do each step. And the time that you see here is in microseconds. So just make a note of that. Let's go ahead and do this now for the optimized query plan. Now I'm going to just copy and paste from the code above. Reuse this piece here, and then we just need to remove this argument. Now the argument here is going to be defaulted to false, so it's going to give us the optimized profile. Let's go ahead and run that. And in the output, we get our results for the optimized query. When you compare the 2 queries side by side, it's clear that the optimized version is faster. Now you might still have some skepticism. Both queries still perform in under a second, and is that savings really that big of a deal? Well, this data set only contains 500 rows. If you were to use these same transformations on a much larger data set, you'd start to see a more impressive difference in performance. In any case, the performance is better with the optimized query. With that said, please feel free to drop any questions you have in the chat below, and we'll catch up with you in the next one.